Okay, so let's talk about what we're calling imaginary and complex numbers. Um, so let's start with this. So if you solve even powers, so this always comes with even powers, and it's because of this interesting characteristic, right? So what does this equation mean? It means what's a number that when I square it, I'll get a positive one. Okay, and so now what's interesting about an even power is that there are two numbers, right? So if you were to solve this equation, you'll get a plus and a minus one. So what this means is it'll take positive numbers and make them positive, and it'll take negative numbers and make them positive. That's what even powers do, right? That's their characteristic. So all even powers will take, any real number, either positive or negative, and it will make it positive, right? So the question becomes, what does this mean? This means that I need a number such that when I square it, I will get a negative. Well, we just discussed, right, that real numbers, these even powers, they make everything positive, which means that this cannot be a real number because the even power would make it positive. So there is no real number such that when I square it, it's a negative number. So what had to happen was we had to come up with this idea of a whole new number system. And they're numbers such that when we square them, they're not positive, they're negative. All right, so our new number system is a number such that when we square it, it's a negative, right? Okay, so I want you to think about this. It's going to be a symbol. It won't be a number that you recognize because those are real numbers, right? So -10, -6, 4, 5. Those are real numbers. So it's going to be a symbol. But we're okay with symbols, right? Pi was a symbol that means a number. E is a symbol that means a number, right? So when you see this symbol, don't freak out. It just is a symbol like anything else. So now they came up with this idea that if you see an I represents a number such that when you square it, it's a -1. So this means that I squared equals -1. Okay? And now, kind of go back to what I'm saying here. This is a number system that someone had to create. Okay? So it's just a whole new number system. And so just like anything that you create, language, I don't know, stories, anything you need to create, it had to, come from nothing. So they decided way back when that they'd use I as that notation that means when you square it, it's a -1. So now I is the number that when you square it, it will be a -1. Okay? All right. So what does this mean? It means that if I square root both sides, that I itself is just a square root of -1. So remember, this notation is the same as this notation. When you see a square root of -1, it means what number, when I square it, equals a -1. So these two are the same, all right? So we will actually use, well, later on when we get into complex numbers and things, you'll use this a little bit. But for us, just recognize that square root of a negative is I. Okay, so let's solve this equation. So same thing, I want to isolate x, so I'll square root both sides, and I'll get plus or minus -1, or square plus minus square root of -1. And then remember that I is square root of -1. So I can take this square root of -1 and put in this number I. So this is really x equals plus or minus I. So there are two solutions here. And what are the solutions? I and -I. Well, let's check them. So I squared is -1 because that's what I was defined, right? So you can even look at here, square this, you'll get a -1. So remember, I was developed to mean that I is the number that when you square it, you will get a negative. So I squared is -1. Well, a -I. So negative squared, so think of this as a -1 times I. Well, a -1 squared is a +1. So this becomes I squared, which is -1. So those both work. All right, so we just came up with a number that when we square it, it's a negative, and that number is I. Okay, all right. So you want to stop this, and you want to complete classroom problems 1 and 2. Okay, so now let's talk about complex numbers. So imaginary numbers are just a piece of the number system. A complex number is a combination of an imaginary part and a real part. So a complex number has this form. It's a plus bi. So when we start solving our quadratics, Sometimes they'll be just real numbers, which is this A, and sometimes they'll be imaginary numbers, which is the B. So A is the real part, and B is the imaginary part, and sometimes the solutions will be a combination of real and imaginary. Okay, so a complex number is really a real part plus an imaginary part. And this B could be a negative. So when I say plus, it could be A, plus 2i or A minus 2i. Right? So when you see this plus, it really is plus or minus because the B could be negative. Right? But that's a complex number. It's a combination of real and imaginary. So it's possible that, the real is 0, so the complex number is purely imaginary. Well, it's also possible that the imaginary is 0, so the complex part is just purely real. Or it's possible that you have both real and imaginary. Okay? All right, so those are complex numbers. Another thing we have to talk about, so let's do this first, I guess. So let's do classroom problems 9 through 12. Okay, so now another part we're going to talk about, they're called complex conjugates. So remember that a complex number is just A plus BI. Well, a complex conjugate has the exact same real part, but opposite imaginary parts. And remember, in math, opposite means different sign. Okay, so if I had this 1 plus 3i, the complex conjugate is 1 minus 3i. So see how the real part, the 1, is exactly the same. It's just the imaginary part that changes sign, plus, minus. Okay, if we had negative 4 plus I, the real stays the same, so negative 4, but we change the sign of the imaginary. So negative I. So negative 4 plus I and negative 4 minus I, these are complex conjugates. And then another, so if we had just an I, so there is no real part, well, which means that it's 0. So it's 0 over here, but then the I changes sign. So these are complex conjugates. Right? So complex conjugates have the exact same real, but they change sign of the imaginary. Just to note, we're not going to get into this too much, but if you multiply two complex conjugates together, you get a purely real number, which is an interesting characteristic. Okay, so let's do this. Let's solve. So you'll see a solution here on how I can get complex numbers from a quadratic. So I have x squared equals, minus 6x plus 10 equals 0. So I have 4 ways I can solve this, right? I can graph this, and I can do the quadratic formula, I can factor, or I can complete the square. Right? So there are no factors of 10 that add up to negative 6, so I can't factor. If you were to see that we would graph this, then y equals 0 and y equals x squared minus 6x plus 10 will not intersect because they're complex numbers, so that won't work. So I'm going to start with the quadratic formula. Okay, so change in b, so negative 6, the change is positive. Now again, this should be a negative 6, so negative 6 squared because it's a negative here, but it'll still come out to be 36, right? And minus 4 times a times c, all over 2 times a. All right, so if I simplify that, I'll get 6 plus or minus negative 4, or square root of negative 4. Okay, so now here's what happens. Here, the square root of a negative is I, and then the square root of 4 is 2. So you treat them separately. So look at the square root of your negatives and change those to i's, and then look at square root of the number and do whatever the square root of the number is. So this would actually turn into 6 plus or minus 2i. Again, where did the 2 come from? Because it's square root of 4. Where did the I come from? Because it's square root of the negative. All right, so now, and you can see, well, square 2i. 2 squared is 4. There you go, I got it. And then I squared is negative 1, and that's the negative. All right. Okay, so now it's just simplifying. So we can split them up, or we can, since the 2 goes into the 6 and the 2, I like to split them up. So then you can see 6 divided by 2 is 3, so this is just 3 plus or minus I. So the solutions to this equation, this quadratic, are x equals 3 plus I and x equals 3 minus I. All right, those are our 2 solutions. And these are complex numbers. And in fact, they're complex conjugates. The 3 is the same, but it's plus I minus I. Right? And when you solve quadratics, it'll always come out like that. You'll always get a complex conjugate. Okay, so you'll always get 2 of them. 2 answers, right? 2 complex numbers, and they'll be conjugates. Okay. All right, I'm going to do the same problem, but I'm going to complete the square. Okay, so let's try that. So here I have a negative 6. Take half of that as negative 3. So I need to add a negative 3 squared. So I like to take the 10 to the right side. So I'm going to do that also. So I'll bring this 10 as a negative to the right side. And then here's the 9 I had. Right? So half of negative 6 is negative 3. So I'll need to add 9. Since I have an equal sign, I can add 9 to both sides. And that's my special 0. Remember, we're adding a 0, but since there's an equal sign, I can add it to both sides. Well, what are the factors of 9 that add to negative 6? Negative 3 and negative 3. So this will be a negative 3, or x minus 3 squared. And then here's a 10, or negative 10 plus 9 is negative 1. Okay, and so now, this is where you might get confused, but it's the same thing as we've always done. I want to solve for x. So right now a square is in the way. So let's square root both sides. So by square root, remember you include a plus or minus, or we have to. So square root of negative 1. Well, this is nice. We recognize square root of negative 1. That's I. So I can take this and make it I. So this is just x minus 3 equals plus or minus I. And then add 3 to both sides, and then x equals 3 plus or minus I. And again, remember, this is x equals 3 plus I, and x equals 3 minus I. There are 2 solutions here, and they're complex numbers. All right, so quadratic formula and completing the square will both solve quadratic equations that have complex roots. Okay, where roots are just solutions. Okay, so that's it. You just want to complete the classwork 13 and 14. That's the end of this video.